Hi, biology. All right, so this is the third and final video related to the sickle cell anemia simulation activity. Okay, so we talked a little bit of background about what sickle cell anemia is and genetic disease caused by a point mutation that affects hemoglobin. And that if you carry the allele but don't have the disease, if you're AS, that's an advantage in an area with a lot of malaria because you become immune to malaria. You cannot get malaria. All right. So again, why we're looking at this is just to see how, like, we as humans are impacted by these same biological rules that we will, adapt, change to selective forces, and we pass that on to our offspring in our DNA. Okay, and so this example has been going on for many years in areas with malaria. And so we usually do a simulation in class so that you can see this. And I'm just going to quickly go through it with you now and give you typical results that you would see. And you can use those results to answer the questions on the simulation sheet that I gave to you as an assignment. Okay, so in class, we use little pieces of paper to represent the two alleles. So we used a pink piece of paper to represent the A allele, okay, the normal blood allele. And we used a white piece of paper to represent the sickle cell allele, okay? So remember, each person would have two alleles, right? One from each parent. So if you had pink, you'd have AA, normal blood, and you could get malaria, but you don't have sickle cell. If you have SS, you have sickle cell anemia, okay? And all the issues that go along with that, and your likelihood of surviving to reproductive age is fairly low in less developed countries. Or you could have gotten A from one parent, S from the other. You're AS, you're heterozygote. You don't have sickle cell. You have enough normal blood that you don't have sickle cell, but your blood is different enough that you do not get malaria, okay? And so to do this, we would start with a parent generation, and you can fill this out on your sheet, of 75% A alleles and 25% S alleles in the population. So how we'd show that is we'd get a glass of papers, and we'd have 75 pink and 25 white. So that would represent how many people? 50, right? Because everybody has two alleles. And so all the alleles in that population, and obviously that's a smaller population than would be very accurate, but we're going to go with it. All the alleles in that population altogether, we call the gene pool. That was on your notes, okay? All right. And so to simulate that, we'd use these papers and this penny, which sometimes I would call the penny of death, okay? Because it determined whether these individuals would survive or not. If you got AA, you would flip this coin. And if you got heads, you were exposed to malaria and you died. If you got tails, you survived till reproductive age. For AS, we didn't flip because you're going to survive no matter what. And for SS, we flipped. And if you got heads, you died of sickle cell anemia before you were able to reproduce. Okay, so there's a very strong selective force on each side. So the selective force is disease. Okay, malaria really is the selective force causing that AS to become an advantage, and this penny is going to kill you potentially. All right, so how you would do this is I'd go through you and your partner and you pick out two alleles. Let's see what I got. They're all kind of sticking together. Okay, first person in this population I pick is AS. They're going to survive. Okay, so we have one A allele and one S allele getting passed on. All right, dang, these papers are sticking together. All right, next one I pull. Pink, AA. I got to flip my coin. Oh, I got heads, dead. These alleles are gone. They're no longer in the gene pool. I died from malaria. Okay. Oh, I got another pink. Flip again. Oh, I died again. Dang, those alleles are gone. Okay. AS. Survive. Okay, can't get malaria. Pink, pink. Okay, gotta flip. Oh my gosh, I survived. So I didn't get malaria. I survived till reproductive age. I keep those alleles in the gene pool. And we continue like this. Okay, SS. Flip. Oh, I die from sickle cell before I'm able to reproduce. Put them in the dead pile. Those alleles don't stay in the population. And I go through the whole gene pool like that. Then at the very end, I look at just my surviving alleles because that is going to be my F1 generation, my first generation of offspring. And only those alleles that are surviving can be passed on then to the next generation. Okay, so this makes the next generation's gene pool. And I would figure out what percentage of alleles are still around. Okay, and I'm going to give you some results that were fairly typical if I like average classes overall. Let's say we had for F1 generation, 71% A alleles. So write this on your paper. And now we have 29% S alleles. Okay. All right. Those surviving alleles. Okay. After we went through the whole thing, back into the gene pool, back into the cup. Now I have less alleles, but I have 71% A, 29% S, and I go back through for the next generation. AS, survive. AS, survive. AA, oop, am I gonna get malaria? No, I didn't, I survived, yay. Okay, AS, survive. AA. Oh, I die. Dang, malaria, gone out of the gene pool. And I continue again. And typical results for that third generation, so the F2 generation, would be, let's do 68% A alleles left, and 32% S alleles. Okay, so that's what you're going to put for that third generation. So over time, we went from parent generation of 75-25, 75A, to the first generation of offspring. F1 generation would have been, what did I say again? Oh yeah, 71% A, 29% S. And then the third generation, F2, the second generation of offspring, we had 68% A alleles and 32% S alleles. Okay, so think about the patterns and trends. You can look back, see how you did on your hypothesis. Okay, what is happening and why? All right, and give those questions a go and finish that up. Okay, so I'm not going to assign anything else the rest of the week. I want you to watch this video. Obviously, you're doing that. Yay, good. And think about these results and what that means and answer those questions. And then if you have specific questions that you're struggling on, send me an email and I will help you out. All right. Have a great day. Bye.